Okay, untuk generator, sekarang we talk about synchronous machine and the application now on the generator. Saya tak pasti apa boleh letak on generator. Kita akan lukis the similar single phase equivalent circuit for that generator. Dia punya generator and motor sama saja. Kalau generator, we shall deliver power to the terminal, deliver current to the terminal. So armature will be delivered to the terminal. Kalau motor, the armature current is insert ataupun supply to the terminal. So generator kita delivered to this terminal. Terminal ni akan sooner connected to the load. Sama ada load you resistive ataupun inductive ataupun capacitive, depends on the application later. Okay, so this is the circuit that you have to draw before you start your analysis. Okay, so simple ya. Mesin dia 3 part. Satu untuk induction, satu untuk furnace, satu lagi untuk DC. So DC is the most simplest circuit lah. Tapi kita tukar dia punya arrangement. So arrangement untuk SEM ni adalah DCB taught at your final chapter. So you mula dengan induction, synchronous, DC last lah. Tapi all the 3 circuit, all the time you follow ataupun we will have the same approach lah. Okay, you draw the circuit, label the diagram. So this is your F, this is your R, F, this is your L, F, field. This is your V, field. This is your IA, this is your R, A. This is your XS. This is your EA. This is your V phase. Okay, this is compulsory lah untuk you punya analysis. Kena ingat lah. From the circuit itself, actually you can derive the formula. So you tak perlu nak hafal formula sebenarnya. You can derive it yourself. So if this part, you draw dia punya current flow. So just follow the Ohm's formula. V equal to IR. Or I equal to V over R. So you can write here IF equal to VF over R total. Later dia ada RF, mungkin dengan RS kat sini. So R total lah. So how much is your IF? You can divide V field that you apply here, divide by RF, sorry, R total for that circuit. Meanwhile, for this circuit, you can write the formula, which is EA equal to IARA plus IAJXS plus V phase. Boleh faham? Then kalau you nak tahu apakah nilai untuk V phase, so you just tukar V phase sebelah kiri. So the other part be on the right hand side. So tak perlu nak hafal, just derive and rearrange. Oh, tak keluar. Tadi? Okey. Okey, konsep dia kita ada dua, sama ada motor ataupun generator. So generator, you akan lukis this circuit, single phase equivalent circuit. You derive the punya formula, you will arrange to get what are the unknown that you want to find. Then you start the analysis. So this one is for what so-called performance analysis and performance ataupun characterization of our machine. Okay, when we talk about synchronous machine, kita kena letak phasor sebab kita deal with AC. So bila ada AC, dia ada leading or lagging of your voltage and current. You ada AC circuit, voltage and current yang akan ada, dia punya bezel fasa dia ni. So dalam phasor, you akan tulis you punya V as your reference, current as your angle lah. Sama ada lagging ataupun leading that current. That's why bila you tulis equation untuk synchronous machine yang involve AC, you kena letak this one dengan marking represent phasor punya mark lah kan. Dalam buku kita highlight, mungkin kita bold kan. Book of ni, tetapi kalau you tulis, you just put a mark lah to represent phasor. Okay, untuk phasor ni dah belajar kan how to generate that phasor diagram ni. Dah sebut kan? Kena recap balik. Recap balik ya. Okay, untuk phasor diagram, how actually the phasor diagram created? Kita regenerate balik our equation ni dalam bentuk gambar rajah phasor. Contoh kata kalau you ada ni peta Semenanjung Malaysia lah. You nak pergi daripada Perlis ke Singapura. So you pergi ikut direct daripada Perlis ke Singapura. Ataupun you boleh pergi ke Sabah, then turun ke Sarawak, pergi ke Johor, pergi ke Singapura. Nampak tak? So this is your reference, this is your ending. Nampak tak? So you can go directly from here 0 to EA, ataupun you pergi kepada V phase dulu, lepas tu pergi kepada IERA, XSIA, baru pergi kepada sini. So it means that is equal. From here to here adalah sama destinasi dia dengan ikut sini. Cuma distance akan jadi jauh lah. Tak sama lah distance ni. Is that it is equal with here dengan yang ni. Nampak tak? Yang ni the supply of the circuit, yang ni consumed by the other part. Supplied by the left side, consumed by the right side. Generate kat sini, consume at the whole side here. Boleh faham tak? It is equivalent. Dengan you punya, this is your EA, internal generated voltage, dengan you punya V phase campur dengan IA-XA campur dengan JXSIA. This is IA, RA, this is V phase. So dia adalah summary kepada this equation. This equation summary represent by this phasor. So untuk phasor ni, macam saya beritahu, V phase is our reference. So V phase akan berada dekat planar ni, dekat single, dekat reference lah, kosong degree kan. Then follow by your IA plus IA times RA. So this is your angle, sama ada lagging ataupun leading ataupun lagging. Kalau leading ke atas lah, kalau lagging ke bawah lah. Then antara sudut ni dengan JXS ni dia akan berada pada 90 degree. Sudut untuk induktor akan berada 90 degree dengan you punya current. Alright. So 90 degree. So komponen tadi ni kan 3 komponen kan. V phase, IARA dengan JXIA ni ada 3 komponen yang membentuk summary of your EA. Okay. Diagram ni tunjuk kita kata pada certain scenario RA adalah sangat kecil berbanding JXS. So sometimes RA is considered as 0. That's why certain circuit kita akan tengok terus dia ada macam ni. V phase terus JXS IA. Yang komponen ni diabaikan. So that's why sometimes kita tengok yang atas tu kita ada komponen IRA dah tak ada. There is no, because untuk certain this up is so low dia punya. Coil yang high quality, dia punya resistance of the wire is very low, so can be neglected lah, dia boleh diabaikan. So theta adalah sudut antara voltage dengan current. Delta adalah sudut antara voltage dengan EA. Sudut antara current dipanggil theta ataupun the reverse sebagai theta lah. Okay, this is your concept or theory lah. Okay. Ada soalan tentang phasor? Okay. You from? You can understand mixed Malay and English? Sikit-sikit, boleh ya? Same. InsyaAllah. Until you understand, please raise your hand and ask. Ada soalan? Semua okey kan? Okey, tak okey pun kena okey ya? Tadi pagi kelas apa? OE. Sarapan belum? Lepas ni ada kelas apa?
Ada mesin 2 jam.
Ada lagi?
Mesin 2 jam.
Oh, Monday blues lah. Tak sempat lah. Okey, tadi kita tengok tentang phasor diagram. Kena sambung kan? Okey, sekarang kita nak tengok dia punya performance. Performance in term of power and torque of the machine. Power and torque of the machine. We are producing electrical, so how much the power ataupun the voltage produced by our machine. Okay, untuk for this diagram, we can see that we have here the generated power will be maximum when our delta here at 90, delta at 90 degree. So P max will be 3 times V phase times EA divided by XS. So this is the theory lah. Nanti when we take a look at our calculation, so we can see clearly what the justification or to justify the theory lah. Okay, P in, P converted, P out. Okay, before we have output, so if we talk about generator, so this is our part to produce the flux. This is the output of electrical part. So this is the between mechanical here and electrical part. Output is mechanical, output power is electrical. P in, our part here, you can see that it become it consume, or they have a loss on the string, dish and the core. And after it jumps to electrical part, so the losses will be I square R or electrical. So over here, mechanical. We have field, field. So part will be connected to prime mover. Rotation. Produce the flux, induce the current, deliver to the load. Okay, all the parts, 3 components before converted power is considered mechanical loss. Stray loss, friction and windage, core loss. We know that component, the single component after converted power is our electrical losses of this circuit. The maximum power is called static stability limit of generator, where the top we can calculate as why we multiply by 3 because we have 3 phase. V phase times EA sine delta divided by omega XS. So per phase we calculate, then multiply by 3 because we have 3 phase. So analysis will be taken in single phase, then multiply by 3 because we are dealing with 3 phase. Kalau single phase, you don't have to multiply by 3. Okay, we have dealt with this before, how to differentiate between delta and Y connected, current and voltage. Okay, I've shown to you before. You don't have to memorize, but you will have better you draw the circuit, then you justify the difference between your current and voltage based on current itself. Let's say you have a delta, it is connected circuit, coil, resistive, coil, resistive. So you draw your diagram. So this is your output. So V terminal of your circuit will be the same as V phase. You can see here, V terminal and V phase are the same. Okay, you draw, you can directly justify from your circuit. Meanwhile, this is your I terminal or I line. V terminal ataupun V line, you can, some books they put as V terminal, some books they put as line. So it's up to you, as long as you understand. So here you can justify that the terminal voltage and line voltage are, phase voltage and line voltage are the same because they share the same line. Meanwhile, your current, this is your I phase, is the sum of 2 phase here, phase 1 and phase 2 combined become line current. So I line should be bigger compared to phase. So how much bigger? Should be 3 times I phase. You draw the diagram, you label the diagram directly. how the equation should be. Now, if you have a Y connected, then you put a label on that diagram itself. So V line now take that V face because we have V face over here, V face over here. So V line should be bigger if you measure here compared to how much big to be third 3 of V face. Nampak? You measure here kan? So V line is bigger compared to V face. Meanwhile, your I line and I face is the same. So I line is equal to I face because it follows the same circuit. The line from here comes out here, go to the terminal. So I line and I face are the same. Faham? So for my approach, better rather than you just memorize, draw the diagram, derive the equation itself from the diagram. So for the machine, either this what I have up. For the either you have a generator or a motor. The machine, if you take a look on the physical appearance itself, you can see that the machine comes out with shaft. So you have a block of your machine. Inside the machine, actually, do we have, or if you take a look at your connection box, there can either 3 wires come out from this machine. Only 3 wires. Sometimes we have 4 wires now. Which one? One is neutral, red, yellow, and blue. And these 3 wires actually comes from the 3 coils. We have only 3 coils inside your machine. And these coils, when you connect, you shall measure that one is resistive, one is inductive values. So we have 3 coils, only 3 coils. And these 3 coils will be arranged for connection in delta or Y. That's only what you can see inside a machine. And so either generator or motor all come with 3 coils. Kalau generator, you put in mechanical force, you can dapat electrical. And vice versa for motor lah. So the connection, you yourself will determine how to connect this one to become delta or how to connect it to become a Y. And when delta, how the equation of current will be and voltage will be. So that's all. Okay. And when you want to test the performance of your machine, first thing you have to do is you have to confirm what is the amount of this RA. When you connect in DC, inductor value will become saturated, so it become like a short circuit, so the remaining values only RA. So you have to determine what is the value of RA such that you can draw this single phase diagram and you can set or you can determine how much value of RA and how much your value of JXS here. Okay, that's why we're performing this DC test. For DC test, I have explained inside the YouTube slide. We have to set either delta or Y. So we have indicate that scenario for our lab. We just connect in Y. So we put DC on the terminal, either from line to line or line to neutral. Line to line, so the equation will be RA will be RDC divided by 2. And because we put voltage of RDC over here, RDC over here, so the current will go into the circuit, passing two components of RA, RA1 and RA2. That's why we have RA equal to RDC divided by 2, because there is two components of R. Boleh faham? Saya lompat sana sini sana, boleh faham? That's for Y. Kalau untuk delta, so it becomes 3 divided by 2 RDC lah. This is the circuit analysis of your first year punya recap subject kan. Parallel system of resistive, series system of resistive kan. Then how we perform the test is that for this task, we try to confirm how much is our value of R. Then we want to see how much actually when we perform open circuit test. And open circuit test means that we set this terminal to be disconnect or open circuit. Does not connect to any load. Open circuit lah. Output is open circuit. We force the current to be at maximum or rated so that we are producing maximum flux to the system. We turn the circuit, the field. We try to see how much actually the what so-called produce voltage at the terminal. Nampak tak? So when we perform the test, we increase the IF here. IF increase. How to increase IF? By increasing VF. We increase VF, IF akan meningkat. So at a certain point, we try to measure how much actually our EA. EA when open circuit, EA and VT are the same value because there is no current passing through, no voltage drop across this component. So means that what we measure here should be the same that's supposed to be measured at the P phase. That's why we have here EA or V terminal at open circuit lah. Open circuit test. So we increase the field current, measure the voltage, increase, measure, then we plot the graph. So this is what you have to do inside your that no. And sebab apa tidak ada, there is no component for RA, IA and SIA because at this time IA are considered as zero open circuit kan. No current delivered to load because we are not connecting to any load. So that's the first circuit you have to generate. Then you have to perform another test which is short circuit test. Short circuit test. You repeat the same procedure, increase IF. Now you measure how much actually the current that flow. Voltage ada tak? Tadi. Is there any voltage? Is there any voltage when short circuit test?
No.
Why? Short circuit test means that you short the circuit, so voltage will be dropped to zero. But for this test, you cannot run as short circuited in the initial state ataupun you start dengan short circuit, tak boleh lah. You kena run after it reach rated speed. Only then you short circuit for a few seconds. Then you release the short circuit. That's why we assign you all to have the on-off switch before you short circuit. You short the circuit, but this switch have to be controlled. You on, then you off after a few milliseconds or few seconds. For practical reason, the mechanism should be applied to protect the motor and protect the machine. Kalau you short circuit terus, you can damage the machine. But if you apply it for a short time and you release, so you can maintain the machine punya performance. Kalau tidak, you can damage the machine. So we increase the field current, try to perform the short circuit test, try to measure how much at this value, how much actually the short circuit current. at this value of field current, how much the short circuit current. And actually, it should be in linear region. The higher the field current you apply, the higher the short circuit current you should get. Okay. Formula, but at this moment, V out are considered zero because we short circuit the output. So when you have these two parts, you just overlap the result to get actually how much actually the rated current of this system to get your field current here, the rated field current that you're supposed to set. You want to find how much actually the rated field current. We can test up to how much it can go, and at this time you want to find how much actually your field rated current. Field rated current. Berapa banyak, how much we can increase this one to be at a safe region of the system. And from this rated field current also, we try to find out what are the rated open circuit voltage. Open circuit voltage. So this is the two components that we want to find when we perform this test, to find what are the limit of rated field current dan juga rated open circuit voltage. Okay, we have a few minutes. We try to take a look on this exercise. Okay, we have scenario whereby 200 kVA, 480 volt, 50 Hz synchronous generator with a rated field current 5 ampere. Rated field current tadi, this one we have test, we consider as 5 ampere as our result. Then we measured that V terminal open circuit to be at 540 volt. I armature short circuit 300 ampere. When we perform the first DC test at 10 volt, 25 ampere measured. So try to find out actually what are the single phase here component, single phase equivalent circuit when we connect the system in Y or when we connect in delta. So the final task that we should accomplish is we can draw this circuit, and indicate what is RA, what is our JXS, what our EA. So what are the first tasks that you have to do? The first task you have to do is draw this circuit. Draw this circuit. So draw. So draw the equivalent single phase circuit. Draw that single phase circuit. Draw the equivalent single phase circuit and jot down all the data that being provided. Whatever data being provided, please jot down or write down on the circuit. So that is the first thing you have to do. So sometimes when you step into an exam hall, the thing you don't have to do is what to start with. So my advice, start with drawing. So draw your circuit, start with your field circuit, then your armature circuit. So there are only few components involved, which is RA, JXS here, EA. So you have your RF, LF, VF. So this is your IA. That's all. You start circuit, draw the circuit and jot down all the given data, 200 kVA. So later you don't have to refer to the question again. You just refer to whatever you have noted. 480 volt, 50 hertz, 5 ampere. Okay, that's all. Then the scenario given, write down again such that you can warm up lah, one of it. V terminal open circuit, 540 volt. Then you have I circuit, 300 ampere. Then you have VDC 10 volt producing I short circuit of 25 ampere. So where to start at the first place is by drawing the circuit and jot down all the data. Then the task requires you all to find what is your RA, then juga your XS. So this is the main thing here. You have to find out. Okay. So stated over here for Y connected. So next is you draw your Y connected diagram. Then when you perform a DC test, so you draw lah DC. So DC you given 10 volt. And 10 volt, you have your RA. Then you calculate for is your RA. So the first thing is find out what is your RA. So for Y connected, so V equal to IR. And the formula that you should remember equal to IR. So I equal to V over R. I equal to V over R. So V here we have a VDC. R here we have RDC. So RDC is R from here to here. But this RDC is equal to 2RA. RDC is equal to RDC 2RA. Alright. So 2RA. So this is your IDC. So you invert you punya RA ke atas, dia akan jadi RA equal to VDC divided by 2IDC. N over 2 times 25 sama 0.20 ohm. So this is your RA. So you have already gained your RA, 0.2 ohm. So first find RA, then after that you perform macam kita tengok tadi lah, open circuit test. So when you perform open circuit test, so from this from the diagram, open EA, you have draw the circuit, so you generate the equation EA equal to IA RA plus JXS IA plus V phase. So at open circuit, V phase equal to rho. So EA is equal to IARA plus JXIA plus 0. So plus 0. Sorry. Plus V phase, tapi yang ni adalah 0. So EA sama dengan V phase. Open circuit kan lah. IA 0. IA is 0 because when we have open circuit, there is no current flow to your load. No current flow to your load. So open circuit, I armature 0, remaining in V phase. So EA open circuit is equal to V phase. So how much V phase? Ataupun how much is your V phase? So go back to your circuit. Your V line to line is equal to cert 3 V phase. But when you measure line to line here, so this is your V phase. This is your V phase should be bigger compared to your line here should be bigger compared to V phase. So now if your V phase is that V phase equal to V line divided by cert 3. So V phase adalah V line divided by cert 3, which is V line kita dah diberi tadi 480 volt divided by cert 3. So how much? 480 ke? Sorry. Terminal open circuit 540. 540. Sebab tu kita kena tulis semula, rewrite such that we can refer to what we have write rather than we refer back to the question. Open circuit is the V terminal open circuit. So EA equal to V phase. V phase equal to V terminal divided by cert 3. Terminal 540 divided by cert 3. You will get 311.8 volt. 311.8 of your EA. So boleh ni 11.8 open circuit test. First DC test, then open circuit test. Next, we have 3 minutes more. Hope you can speed up. Short circuit test. Tadi open circuit, now short circuit test. Short circuit test. Open circuit test, short circuit test. Same equation, EA equal to IARA plus JXSIA plus V phase. At open, short circuit. So V phase will be 0. You short the circuit, V phase akan kosong. So EA equal to IARA plus JXSIA plus V phase, which is 0. So the remaining only IA XA. So you kira untuk ni, dia tak sempat. You kira untuk impedance to R plus XS. Kira untuk yang, so you akan dapat ni XS. Short circuit test kita kira untuk DC test RA. Short open circuit dapatkan EA, short circuit dapatkan JXS. Nanti kita buat lah. So that 3 tests you akan produce the values that you can fill in this single phase diagram punya character. Baik? So that's why we need that 3 tests punya procedure lah. And to find out that 3 hilang. Habis lah. That 3 element. Nampak tak? So your next class bila? Tak untuk kelas ni. So, Rabu kan? Apa? Di Rabu we shall recap this part. And kita proceed to next. Yeah. Okay, thank you very much. See you again insyaAllah di hari Rabu. Tanya nanti saya share dalam apa dulu.